So this session is on multiplying fractions. So I know a lot of people really struggle with fractions, and the concept of multiplying fractions is not as hard as you may think it is. And if you have to go on to college algebra, you will learn about multiplying rational expressions, and those are basically fractions that involve algebra. So this skill for multiplying fractions does apply if you have to go on to college algebra. So it's one of these things that we're focusing on here. So if you do go on to that class, you have the concept down so that you can extend it to when we involve variables and all that kind of thing. So just as a review of what a fraction is a way to express I missed a word when I was typing. I don't know if you guys do that. How many parts we have out of the whole. The top is how many parts you have, and the bottom is how many parts make up the whole. So that's essentially what a fraction means. And we write it as A over B with that horizontal bar. And that actually also means division. So that's something that some people miss, is that a fraction is also indicating division. So when we're solving, we tend to, when we divide both sides of an equation, we write it as a fraction instead of writing the division symbol. So that's just something, if you see that, it's meaning division. And we cannot have the denominator or the bottom of the fraction equal to 0, because if it equals 0, you're dividing by 0, and we cannot divide by 0. So you can't have 0 in the bottom. Your answer would be undefined. We refer to the top as the numerator and then the bottom as the denominator. So those are just the technical terms. I just say top and bottom. I don't feel the need to have to use the technical terms. So for multiplying fractions, you're multiplying straight across. So you're multiplying horizontally, you're not going diagonally. And so this just comes from the book, the basic formula. If you have two fractions, A over B times C over D, then you do A times C and B times D. So you just multiply the tops together, you multiply the bottoms together, and then you always simplify or reduce your fraction afterwards. So simplify means reduce. And you can either choose to reduce your fractions before you multiply, or you can do the reducing after you multiply. So you'll get the same answer either way. And the first example that I'll do, I'll show both ways, how you can reduce first, then multiply, or how you can multiply and then reduce. I tend to reduce first, then multiply, because it works with, you deal with smaller numbers that way. But you can do it either way, you'll get the same answer. So we'll start with our example here. We're going to be multiplying 15 over 28 times 7 over 9. So just one thing to note here is that the dot that I have here, that means multiply. And our textbook does use the X for multiplication, but when we start going into algebra next week, when we start using variables, we often use X as a variable. So we switch to the dot. So I would just get into the habit of using a dot for multiplication instead of the X, so that you don't get confused. And another way to indicate multiplication is with the asterisk. So you can use that on a computer keyboard. You can use the asterisk to indicate multiplication. So that's another option. So just to kind of talk about that notation there. So I'm actually going to do the multiplying first. I'm going to do the right side. I should have done the multiplying first on the left and then simplifying, but we'll do the right side. We'll solve this by multiplying first and then reducing. So we've got 15 over 28 times 7 over 9. And so you're definitely going to want to have your calculator here, and you're multiplying your numbers horizontally. So you're doing 15 times 7, which gives us 105. And then we're doing 28 times 9, which is 252. But we're not done here because we need to reduce this fraction. You always try to reduce and get it in lowest terms. And when you're reducing a big fraction like this, you have to kind of think about, okay, you know, you're kind of going through, can I divide 2 out of both the top and the bottom? Can I divide 3 out of both the top and the bottom? It's kind of like guessing and checking, where you're trying to determine what can you cancel out. So I know I cannot divide them both by 2 because things that are divisible by 2 will end in an even number, and 105 does not end in an even number. So I know they're not divisible by 2. So then I'll just say, okay, can I divide these both by 3? So you just literally kind of try it out on your calculator. Do 105 divided by 3, and that gives us a whole number. And then 252 divided by 3, and that gives us a whole number. So if they both get you a whole number, that means you can reduce that. So the way that we show our work for reducing, I'm going to rewrite this here. We're going to reduce by dividing the top and the bottom by 3. And so you're literally writing that you're dividing the top and the bottom by 3. If you only write one of these and you write divided by 3, you're actually divided by 3 over 1, which is not the same thing. Because we're basically dividing by 3 over 3. Because we're not actually changing anything. 3 over 3 is equal to 1. We're not changing the value by dividing by 1, but it does let us write it a little bit differently. If you're only dividing by 3, you 3 over 1, you're actually changing the value. It's not equal to what it was anymore. So I'm going to just, on my calculator, do the 105 divided by 3, which is 35. And then 252 divided by 3, which is 84. And then you want to try to reduce again. So you kind of go through the process again. So I can't divide by 2 because 35, that's not divisible by 2. Now I know 35, it's 7 times 5. So let's see if 84 can be divisible by either of those numbers. So 84 I know cannot be divided by 5 because things that are divided by 5 end in 5 or end in 0. So we're going to just see if that's divisible by 7. So it is. So that means I can divide 7 out of the top and the bottom. So, oops, I don't need my equal just yet. So I'm going to rewrite it, and then I'm going to write that I'm dividing them both by 7 to reduce it further. So 35 divided by 7 is 5. 84 divided by 7 on my calculator gives me 12. And then these numbers are small enough that I know I do not have any numbers in common between 5 and 12. So I can't divide anything else out. So that is our reduced form, and that is our answer to the multiplying. So when you're multiplying first, you multiply straight across, and then you are reducing until you can't reduce anymore, and that gives you your final answer. Now, the other method to do this is by simplifying first, and this is the method that I usually do. So I'm going to start by rewriting our problem. And what you do is you try to reduce what you can before you multiply, because the numbers are smaller. And when we're reducing here, so you can, when we have that rule for multiplying, these are basically, you put them basically over the same fraction. So what this means is that I don't have to reduce straight up and down. I can reduce diagonally as long as I'm removing one from the top and one from the bottom, or I'm dividing something on top and something from the bottom, because they're basically considered part of the same fraction. So I look at my numbers and I say, okay, what can I divide out of the top and the bottom So like 15 and 9, I know that 3 goes into 15 and 3 goes into 9. So I can divide these both by 3. So I'm going to just kind of write those in. And I'm doing one on the top and the one on the bottom. So that's following the rule of reducing. And I know that with 28 and 7, I can divide those both by 7. 7 goes into both of those. So as long as I'm doing one on top, one on the bottom, it doesn't matter if they're diagonal, just as long as you have one on top, one on the bottom. So when I do this, this is going to give me a new fraction, basically. These are going to be reduced fractions. So I got 15 divided by 3, which is 5. 28 divided by 7, which is 4. Multiply by, then 7 divided by 7 is 1. 9 divided by 3 is 3. So now I've reduced this problem by simplifying so that I'm really doing 5 over 4 times 1 over 3, which is a lot easier to multiply. I don't even need a calculator to multiply this. I can do this whole problem without a calculator. So I just multiply these straight across. 5 times 1 equals 5, and 4 times 3 equals 12. And I get the same answer that we did using the method on the right, but with less steps, and I didn't even need to use a calculator. While on the right, I had to use a calculator, and I kind of had to guess and check on what I could reduce or divide out. So this is why I tend to use the method on the left, where I will try to simplify or reduce first before I multiply, because it actually is easier than multiplying first and then trying to reduce. Are there any questions? So, okay. So I've got 2 examples here, and I'm going to do these my method since we tied. And I did vary the symbol. So like the first example here, I'm using the multiplication X that you see in the textbook, but I just want you to know that there are other ways to write multiplication. So our previous problem, we had multiplication with that dot. The second example on this slide, you have multiplication with parentheses. So if you have 2 numbers with parentheses, like one of them's in parentheses or both of them, that also is multiplication. That's implied multiplication. So there may not be a symbol there, but if there's no plus or minus, then it's assumed that it's multiplication. So I wanted to show different ways that you may see multiplication, so that way you're familiar with them and you know what they mean. So the first one, we've got 10 over 13 times 26 over 15. So I'm going to start by rewriting this, and I always use the dot, so I'm just converting it to a dot. So I'm going to do the simplify first, then multiply. So when I look at this, I immediately see, oh, 10 and 15, I can divide those both by 5. So knowing your times tables is really nice for reducing fractions because it makes it go quicker. And I always write down what I'm dividing by, because sometimes if you try to do it in your head, you accidentally mess up. So I've seen people say, oh, I need to do 15 divided by 5, and then they write the answer 5, but the answer is 3. So I actually write what I'm doing so I can double check to make sure that I've done my math right. And then looking at the 26 and 13, so I know that 26 goes into 13 just because I play cards a lot. So I can divide those both by 13. You may not be familiar with that, and that's completely fine. Sometimes when you reduce, if you don't reduce all the way and you multiply, you may still have to reduce after that. So you just have to see, did I reduce it enough first before I multiply? If not, you have to do it again. So I'm going to now rewrite what I've got. I've got 10 divided by 5, which is 2. 13 divided by 13 is 1. Then 26 divided by 13 is also 2. 15 divided by 5 is 3. So I've got 2 times 2 going across. So if it helps you to kind of remember that you're multiplying by circling those, that's 4. And then 1 times 3 is 3. And we end up with an answer of 4 over 3. And those cannot be reduced anymore, so that is our final answer. Now for the second problem on this slide, I've got 3 over 4 times 14. So whenever you've got a whole number, you can always, or 3 over 7 times 14, I don't know why I said 3 over 4. Whenever you got a whole number, you always turn it into a fraction by writing it over 1. So this is 3 over 7. Let me make my 7 look a little better. There we go. Times 14 over 1. So when you're multiplying by a whole number, you're basically only multiplying that whole number by the top of the fraction. The whole number does not get multiplied by the top and the bottom. It's only the top. So I'm going to reduce again, just because that's what I find easier here. Because I see that I've got 7 on the bottom, 14 on top. I can divide those both by 7. Now with 3 and 1, there's not really anything else I can reduce there, so there's no point in trying to reduce any further. So I'm left with 3, and then 7 divided by 7 is 1, so that's 3 over 1. Times then 14 divided by 7 is 2, and that's 2 over 1. So this really reduces to 3 times 2, because over 1, it doesn't really mean anything. So we're really multiplying whole numbers here, 3 times 2. And you get an answer of 6. Now, we always try to simplify. So if you wrote 6 over 1, this is not simplified. We don't, if it's over 1, we're not considering it in its simplest form. The simplest form would be to write it as a whole number as 6. So just keep that in mind, that if you're working with fractions, don't leave it as a fraction if you can turn it into a whole number, because it's not simplified in its fraction form if it can still be worked on or divided out. A trick, a kind of mental trick that I do with problems like this last one, where I see like a whole number multiplied by a fraction, is I look at it and I see, oh, that 14, I can just divide it by 7 and then multiply it by 3. So I kind of do the reducing in my head, because when you have a fraction 3 over 7, the over 7 means division. So I see this and I say, oh, 14 divided by 7, I can do that. And then I have that multiplication still there, and so that's where I multiply. So that's one way that you can do a problem like this in your head. I don't use that when I have like the top example, because it's a lot harder to kind of do that and keep track of what you've divided and what you've got left. You know, it's harder to do that reducing if you have to reduce multiple things. It's a lot easier, like in the bottom example, when we're only reducing one set of numbers. And so I usually only do that kind of mental trick when there's a fraction times a whole number. Are there any questions?
No questions here. I just so like when you're showing your homework, like for the quizzes, like using the different tools like that are on the web. Like I think we discussed. I've been out of algebra for quite some time, but so like the 6/1, like if you're to show that on your work when you like take a PDF or upload, you want to see the 6, not the 6/1, correct?
Yes. Yeah, because the simplify the actual answer, and that's what you're going to want to enter in, like on your quiz, would be 6. If you put 6/1 on your quiz, it's going to be marked wrong.
Okay. All right. Perfect. Yeah. So, that was my question. Cool. Thank you.
Okay. Yep. That's a good question. And as far as showing your work, like on this bottom one, if you can do that in your head, you don't really need to write anything down. Other than what I would write down like on your work is maybe the original problem and then put equals 6. So if you can do it in your head, just write the question and then write the answer. But like the top one, I can't really do that in my head. So you do want to show work for that.
Yeah, and that was kind of the thing. Like I was a little bit worried about when I took a picture of my work. I was like, all right, so there was like 2 ways to do this equation that were on the quiz. So I was like, hopefully I wrote down the right thing, which I did in my grade. But I just wanted to ensure, like, I was like, because there was 2 ways to do this thing. Is that a really long way, or there's an easier way to do it? So I just want to make sure. And it was fine when I got my grade back from whoever graded my work. So I was just saying there's like 2 ways to do it. So I was a little bit worried on the first project, but no worries. Thank you.
Yeah, I would, if you have multiple ways to do a problem and you're on a quiz, do the easiest way, the quickest way. Because, the quizzes are timed. We don't want you to spend your time doing the long way if there's a faster way to do it. So, all right. So, because this stuff is kind of straightforward, I didn't have like tons of examples. These are actually my last 2. So I wanted to do one with 3 fractions to show you how you can kind of extend this. And then a word problem that involves multiplying fractions, so that you can, see an example of a word problem as well and how to like read what you need to do and how you translate that. So on the top, we've got 3 fractions. And so again, I'm going to just start by rewriting this. And that's a good practice, is to always, in your notes, write the original problem down. And then actually, when you start working it, write it down again so that you have the original problem separate from your work, so you can still remember what the original problem is because you start marking it up. And so I'm going to try to start reducing things, and I just kind of look at what I see. So like 55 and 11. So I know that 55 is 5 times 11. So that means I can divide 55 by 11 and 11 by 11. So I'm going to just mark that in there. I'm kind of looking, and there are multiple ways that we can do this. So like looking at the 18, I can divide 9 into 18 and I can cancel those out. But also with 18 and 32, a 6 goes into both. No, not 6 doesn't go into there. 2 goes. I don't know why I was thinking 6. I was thinking 6 goes into the 24. I can divide those both by 2 if I wanted to. 2 goes into 18. 2 goes into 32. But I could also instead maybe say, oh, I can divide 24 and 32 by 2. I could divide those both by 4. There are multiple ways that you can reduce. And so that means there's multiple ways to do this kind of problem. And there is no one way to do it. So I just do whatever first comes to mind. And if I end up having to reduce again later, that's completely fine. So the first thing that I saw here was the 9 and the 18. So even though I could use the 18 and reduce with other combinations, I'm going to divide those both by 9. Because that's just the first thing that I notice, is that 9 goes into both of those. And then I kind of look and I'm like, okay, well, can I, divide something out of 24 and 32? And so, like I said before, I can divide those both by 4. So I'm going to just kind of write that in, both of these divided by 4. So Now I'm going to actually do my division here. So 55 divided by 11 is 5. 9 divided by 9 is 1. So that's one fraction. 18 divided by 9 is 2. 32 divided by 4 is 8. Then I've got 24 divided by 4 is 6. 11 divided by 11 is 1. So as I look at this, you can see that we can actually keep going because I've got 2 and 8. So I can divide those both by 2. Or if I wanted to, I could do the 6 and the 8 and divide those both by 2. So you can keep reducing. Sometimes, if you don't reduce it immediately the way that I did it, you say, oh, I can keep going. Now, an alternate way that people do if they have to kind of reduce multiple times is, so they'll say, okay, I can divide a 2 out of both the 2 and the 8. And they'll do that, and then they'll write the result right there. So they'll cross it out and then write the reduced form. So 2 divided by 2 is 1. 8 divided by 2 is 4. And then they can keep going. So then they might say, oh, well, I can also divide 2 out of the 6 and the 4. So that's 3 and then 2. And so they just kind of keep crossing things out. Now, the danger of doing this method versus what I did on the left where I physically wrote down what I was dividing is that it's easy to get lost with what number you have left over. And it's easy then when you start to multiply across to kind of see what numbers are you multiplying together. So, because you just end up kind of having numbers all over the place. So it's not necessarily the best method, but it works. So I'll just leave that there because that is a method that we can use. So with the result of all of this, we don't have anything more that we can cancel. So you multiply straight across. So I've got 5 times 1 times 3, which gives me 15. And then in the denominator, the bottom, I've got 1 times 2 times 1, which is 2. So 15 over 2, I can't reduce that. And we're not going to turn it into a mixed number. Basically, in algebra, we don't use mixed numbers. We leave it as improper fractions. So don't bother to turn this into 7.5. It's more work than you need to. Leave it as 15 over 2. Are there questions on this problem before I move on to the word problem? Okay, I'll take that as a no. So moving on to the word problem we have here. Chantel had only enough paper to print out 3/5 of her book report before school. If the report is 10 pages long, how many pages did she print out? So the key here, and what makes this a multiplication problem, is the word of. So in math, the word of means multiply. So if you have a word problem and you see the word of in there, that's going to be an indication that you're multiplying something together. And what we've got literally here is we've got 3/5 of, so that's a multiplication of her book report. And so the book report is 10 pages long. So this is really 3/5 times 10. Because that's basically what the book report is. So this is doing 3/5 times 10. So I basically took this whole section, which is, most of the word problem has words we don't need. All I needed was this part and then just the fact that it's 10 pages long. And that's all I needed in order to figure out what we're doing here. So I've got 3/5 times 10, which I'm going to turn into a fraction to do 10 over 1. And this is another case where I would use the trick where I do 10 divided by 5 and then multiply by 3. Because it's a whole number times a fraction and it works out very nicely. because 10 divided by 5 is 2, and then it's just 3 times 2, which is going to be 6. And this might be one of those situations where it might make sense to just do the slash method and write the result. Oops, except that I did exactly the error that I told you guys to avoid. I did 10, we're dividing by 5, and I wrote 5 instead of actually writing the result, which is 2. That's one danger of doing the slash method, is you write down the wrong number, which I just literally did. But when you have a simple multiplication here, sometimes it's a lot easier to use the slash method than to write the division, the like I did on the top. But you got to be aware that you don't write down the wrong number like I did. But then we see we just do 3 times 2, and so this is 6. And this does have units. It's not just the number 6, it's 6 pages, because this is in context. And with most word problems, you want to make sure that you write your answer as a sentence, because it gives it meaning. You might actually just say, if somebody said how many pages, you could just say 6. But we like to actually put it in context with like units and everything. So we would just write Chantel printed out 6 pages. It just gives context to your answer. Help if I spelled her name right. There we go. It gives context to the answer, and when you're going through your notes later on, then you know very clearly what your answer is, especially if you have a word problem that takes up multiple steps. You can kind of get lost along the way or forget what are you trying to answer. So it's always good after you've done your math to go back and make sure you're answering the question. So the question says, how many pages did she print out? Then you say, okay, she printed out 6 pages. You just try to answer the actual question as your final answer, as a check to make sure that what you've done is what you were supposed to do. So because it's really easy to accidentally do the wrong thing or get the wrong answer, do something not what was asked, because you just kind of get into the zone of doing the math without thinking about what are you really actually looking for. Are there any questions?
Yeah, no questions here. That actually makes perfect sense, because I guess the 1 canceled it out, so the 6 pages. So I guess that answered the question. So that's actually really good. It helps out, especially when you're just trying to read the book. When you're trying to read the book and then trying to figure it out, you're like, oh, all right. So that makes a lot more sense. So I appreciate that. Right?
Yeah, trying to learn from a math textbook is difficult. I think seeing things worked out like as it goes makes a lot more sense. That's why we have like the videos kind of linked before each homework, so you can kind of see a video demonstrating it as well. So that way you're not relying totally on the textbook. And just for like, if you're wondering, how do I use a math textbook? The way that I use a math textbook is I will actually open up my assignment, and then I'll go to the sections of the textbook that match with that assignment. And then as I go through the homework problems, I'll look for similar examples in the text and try to, do an example like the homework and then do the homework problem. And if I don't quite get it, then I might have to go back further in the text. Like maybe it's like, oh, I don't quite get this example. Maybe I need to do the previous example. And I'll just kind of work backwards until I get to a point where I understand, and then I'll work my way forwards again. So that's how I use math textbooks, so that you're not sitting there like reading it like a regular book, because it's not really useful that way. If you try to read a math book like a regular book, it's not easy.
No, yeah, and I agree, and I'm sure some of our classmates can probably attest to that. Is like, so like when you're going through the quiz, and then let's say show me an example, it'll show you an example which is similar of what you're trying to work on, but then it just goes into like some elaborate thing, and I honestly say, and then obviously there's a lot more resources online these days, but I was like, wow, that went way into the weeds when it was actually very, very simplified. You know, like I said, I've been out of the algebra game since I graduated high school in 1993. So I was like, oh, all right. So like breaking it down like that, super simple. But the textbook seems to I wouldn't even say simplify it. It was just like, I was like, wow, mind blown. And then, you know, use some other resources online. You're like, oh, all right, cool. That wasn't really that difficult.
Yeah, math textbooks are written to be mathematically exact. So they're giving you every single step, explaining why every step is done. But in reality, when you're teaching, you know, it's like, okay, we're not expecting you to know the name of every, you know, what property we used for every single one of these things. We want you to be able to actually just do it, whether you know the name of the property or not, you know, and we can show you the shortcuts and show you how there's multiple ways to do a problem and that sort of thing. So the textbook is way more technical than maybe like an actual person would be teaching. And this is just true of like a lot of STEM fields. So if you have to take like physics or any of the engineering classes, expect the textbooks to be very similar in this aspect. So this is like if you can master using a math textbook the way it should be used, the way I described, you'll be okay if you have to take some of those other classes. It's a total different way of using a textbook than some other textbooks.